In this video, we're going to talk a little bit about hurricanes. A hurricane is a strong system in the ocean that's characterized by a large low pressure center and numerous thunderstorms that produce strong winds and heavy rain. Of course, a simple definition of the word doesn't really do justice to these powerful storms. And lots of folks who live either on the Gulf Coast or the East Coast of the United States have to deal with these every single year. Now, the word hurricane probably comes from a Caribbean word that means evil wind, and this is most used in and around the Atlantic Ocean. But there's lots of other terms that you may hear that mean exactly the same type of storm. For instance, you could hear a tropical cyclone, a typhoon, a tropical storm, a cyclonic storm, tropical depression, or just a plain old cyclone. All of this basically mean the same thing. As you'll see with the tropical storm and tropical depression, they have a little bit different connotation, at least for the Atlantic Ocean. And that's mainly what we're going to focus on since we are here in the U.S. And so those are the ones that mainly affect us. But there are a number of Pacific Ocean hurricanes that do reach the west coast of the U.S., and we're often right in the line of some of those storms as they're dissipating here in kind of South Arizona. And those Pacific storms can bring us quite a bit of rain. And we've had some pretty severe flooding in and around the Phoenix Valley and over in Mesa and Gilbert because of some of those Pacific hurricanes. So we need to talk a little bit about exactly where and how these hurricanes form. The most important thing you're going to see from this picture is that most hurricanes actually form fairly close to the equator, but not right on it. And we'll talk about that here in a second. But you see these orange regions are where they're going to generally form, along with the names that they go by. And you can see kind of north and south in the oceans are pretty quiet, but that comes down to the water temperature. So in order to form a hurricane, it needs just the perfect situation. The most important thing is going to be warm water. Now, the sweet spot is right about 79 degrees Fahrenheit. Any less than that, and it's not going to be warm enough for a hurricane to form. There's some other stuff that goes on there, though, because you've got nice warm ocean water, and that warms the air up above it. So you've got warm, moist air that rises pretty quickly because hot things rise, right? That's how a hot air balloon works. So as that hot air rises, it moves away from the center of where it is, and it tends to cool down at that point. And you get a lot of rain because cold air doesn't hold as much moisture. So the rapid cooling is going to be really important. So you need a significantly cooler upper part of your atmosphere to be able to do that. You're also going to need high humidity because that's what's going to supply the moistness that's in that warm air. But you also need pretty low wind shear. So wind shear are those winds that blow across the surface of the ocean. And when those are too high, it actually disrupts this motion and you don't get that nice rising air. What that ends up doing is creating a low pressure center right in the middle because of that rising air. And that low pressure center is really important for our hurricanes. Now, you need some sort of pre-existing system of disturbed weather. It just gives it like a little seed to start and to get those moist air moving in this case. And eventually you're going to form dense clouds and thunderstorms around the edges of this. Now, the last part here is kind of how it sets up the hurricanes as we know it. Because you need to be more than 345 miles or about 5 degrees from the equator. So you need to be about 5 degrees north and south because that is where the Coriolis Effect kicks in. And the Coriolis Effect is what makes a hurricane spin and move. And so that is due to rotation of the earth and some drag in the water there. So you can see I've given you a couple of pictures to sort of differentiate the two. On the left is Hurricane Ike. This is a storm that formed in 2008, strengthened up really big, and then made landfall right across Galveston, Texas. And we're going to end up looking at some pictures from Hurricane Ike because that was particularly devastating for that region. On the right is Cyclone Yazzie in 2011. This was another really big storm, except this one actually made landfall on the northwest side of Australia, caused massive flooding throughout that area. But as you can see, they're spinning different directions. So in the northern hemisphere, so everything north of the equator, the storms are going to spin counterclockwise, and that's why those rain bands kind of swirl the other direction. But in the southern hemisphere, it's going to actually turn clockwise. And it leaves those storms back behind it as well. Now, one thing I got to say is the Coriolis effect has nothing to do with the way the water spins in your toilet, though. Now, this is a pretty common myth. I think we've all heard it. Even Bart Simpson. I don't know if you remember that episode, but he ran up quite an international phone bill. And ended up taking a trip down to Australia. This is actually a trick a lot of people like to play, especially in the tourist traps right along the equator. You'll see folks set up with toilets like on either side of the equator, trying to show you that it's spinning in different directions. Now, toilet water is pretty small, and so that's not quite big enough to feel the effects of the spinning of the Earth, but an ocean is really big, and it actually does. And so most of the toilet issues has to do with the piping and which way the pipe actually turns when it comes out of the toilet. So sorry to ruin that for you. All right, so if we look at this is a really cool map. This is hurricanes and tropical storms between 1985 and 2005. There's a lot, right? And you can see some of those nice little sweet spots along the way. In particular, you can see this Western Pacific is really, really active. And of course, we're going to be focusing most on the Atlantic Ocean, but I'll mention a few of the Pacific typhoons along the way. There's one weird little hurricane actually off the eastern coast of South America. This one was a particularly odd storm, which was pretty cool. But you can see the storms develop and then they move, and that's of course part of the spinning of the Earth as well. So they all have a kind of similar pattern they follow. Most of the hurricanes that affect the United States are going to form off the coast of Africa or further over in the Caribbean. Now, this is an important part. This is actually what is sometimes referred to as Hurricane Alley. And this is because this is particularly warm water. And it's quite a bit warmer there through that strip than elsewhere in the surrounding ocean. And unfortunately, what's happening is the temperatures are actually increasing along Hurricane Alley. And warm water is what these storms feed off of. So that's actually pretty dangerous. Now, we can talk about hurricane seasons. I think these are pretty interesting because a hurricane season is really sort of based on when the water is the right temperature. Because hurricanes are going to feed on warm water. So as it gets into warm, as if a storm forms, and it gets into warm water, it gets stronger and stronger. And if it goes into cold water, it actually gets weaker as it goes. And so our hurricane seasons pretty much line up with when the water is 79, 80 degrees down to a certain depth. It's like 26 feet. So for the northern Atlantic, the hurricane season runs June 1st through November 30th. But it's not a hard and fast rule right now in 2020. We are on just one of consecutive years that have had named storms that formed before the official start of hurricane season. But if you want some records, the earliest storm that has formed in the Atlantic was actually in 1938. It was just Hurricane 1. They hadn't developed the naming system yet, but that actually formed on January 3rd. That's like, the middle of winter. So these obviously aren't hard and fast rules, but I kind of enjoy the Western Pacific and Northern Indian Oceans, and actually Southwest Indian Ocean too, because that's just all year, literally every day of the year, which is kind of funny to need to point that out. But I did find it on Wikipedia, so I'll trust them right now. I found a couple of these maps showing sea surface temperature anomalies of a couple of hurricanes, and I thought it was really interesting. So this is Hurricane Michael in 2008. This is over the course of a few days in October. And you can watch as the hurricane is sort of forming down south of the Yucatan Peninsula and then moving up into the Gulf of Mexico. And you can see where it's red is the redder it is, the warmer the water is, or at least the more warm the water is than normal. So these are our temperature anomalies. So these are just warmer than normal spots, and the blue is colder than normal spots. But it's interesting because you could see right before it makes landfall in the panhandle of Florida, as it's approaching, that water gets really, really hot. And so you can see where the storm actually blew up into a Category 4 storm from a Category 2 just because of that warm water current. The other sort of thing that's interesting is to watch the water cool off behind it, because you can see as it passes, the water gets quite a bit colder. We see that as well with Hurricane Florence. This was a hurricane that made landfall in the same year as Hurricane Michael, just a little bit earlier there. And if you look where it's coming through, as it passes by, especially when it gets over in kind of that warm water, you can actually see the water cool down behind it because it's sucking up that energy from the temperature and using it to grow bigger and bigger before it makes landfall.